About to start. No swearing in the Big Brother house. What we'll do, first of all, though, is go through a protocol data unit. Okay, so you get to know. Now, I would advise when things are recorded, when we put things up on screen or whatever else, or if I'm talking, when I'm talking, an average class, an average student will take in around about maybe 10-15% if you're lucky of what I'm talking about during the normal class time. If you're taking notes, that jumps up to about maybe 30-40%. If you go back and read things and do some exercises and read this stuff again, then that jumps up to 70 and 80%. So if you're sitting on 70 to 80% knowledge and the pass rate for the assessments is 60%, in theory, you should pass. Okay, so that's my hint to say take notes. Right, here we go.
It's time for everybody's favorite game show, Name That PDU. Hey, I wanted to chat with you for a minute, all kidding aside, and make sure that you have absolutely mastered the labels for the different PDUs in the OSI reference model. So a couple of things I want to do. I've got frames, segments, bits, and packets, but the challenge is that's not the right order for those labels.
Right. This is where you should be writing that down. Frames, segments, bits, packets, because that's going to come back and bite you. And there's going to be questions about it. So this is where you have to start paying attention, okay? So I'll give you a second. Frames, segments, bits, packets. Write that down. Just so you know what they are. Then we'll get them to explain what they are. Or for those of you that are sitting there taking screenshots, well done. Oh, where'd it go? Where'd it go? Where'd it go? I just lost it. Where'd it go? Oh, I just lost it. That was stupid. Hang on a second. I'll get it back. Didn't mean to do that.
It's time for everybody's favorite game show, OSI reference model. So labels for the different PDUs in the OSI reference model. So a couple of things I want to do. I've got frames, segments, bits, and packets, but the challenge is that's not the right order for those labels. So what I'm going to do is I'm going to make this easy because we're going to remove some variables. Let's go over here. And we know that at the session layer, presentation, and application layer, those three, that's the senior management team for the OSI model as the reference model. And so up here, we call the data PDUs. Fair enough. But down here, the bottom four layers, we have names for those PDUs. Now, why does it matter? Because when we're talking or reading a periodical that says, Cisco has a new device that operates at layer 2, or Cisco has a new device that operates with segments or packets, we can correlate the concept of a packet or a segment with a certain layer of the OSI reference model. So I wanted to take a few moments with you and just play this little game with you and make sure that we're comfortable and that we understand exactly the labels for each of the layers. So what is the protocol data unit, the PDU, for a frame? And what we'll do is I'll draw, you think, I'll draw, where does that fit? Does the frame, is that the label of the PDU at the transport layer, the network layer, the data link layer, or the physical layer? So if you're a betting person, you get a 1 in 4 chance. Not bad, 25%. But if you were in class, you should, and that's why we're doing it, you and I, is to make sure you have this down pat. Where do those fit? What device forwards frames for a living? Dealing with the addresses where frames operate. Go ahead. I'm not rushing you. Take your time. All right. So a frame is the PDU at layer 2 of the OSI reference model. And the device that deals with those would be a layer 2 switch. It's making forwarding decisions based on the layer 2 addresses, and that's where we call the PDU frame. So a frame would be information that had the layer 2 header, and it had the source and destination included inside that header. Fantastic, one down. So not to get our freeways all crossed up, I'm going to clear this up, and let's take a look at segments. If we talked about a segment of data, the segment PDU, where would that fit in the OSI reference model? Again, we really have the bottom 4 layers to choose from, and we've already eliminated, I'm just going through the process of elimination here, we've already eliminated the data link layer. So it's got to be transport, network, or physical. In the analogy in class, we talked about segments, and the segments deal with the middle manager at the transport layer, because he could get a whole bunch of data, like a big truckload, and he segments it up into smaller individual pieces, and that's a good way to remember segmenting. So the segments are the PDU label for the data at the transport layer. All right, 2 to go. Now, by process of elimination, we might need to get lucky here, but again, it's a great review for you and I. So let's take a look at bits. Bits are bits. Bits are ones or zeros being sent across the network, and although a bit could be representing lots of different things in the OSI model, where does it fit? When somebody says, oh, this is a device that only understands how to deal with bits, where does it fit? Is it transport, network, data link, or physical? In our analogy, it was the truck driver. Imagine the truck being filled with bits, truck driver driving them across, and bits are absolutely a physical layer label. And that really isn't a PDU, a protocol data unit, it's just bits. So bits are associated with the physical layer. And that leaves packets. So do you recall? If somebody says, oh, here's a packet, we're dealing with a packet. We're dealing with information that has an IP header, and then that IP header has the source and destination address, layer 3 address. So where do packets fit into the mix? Go ahead, take your time. In our analogy, we had the mailroom for addressing, and the packet is the PDU that has the IP header already attached, and that's at layer 3 of the OSI reference model. So one other thing that I would like to do is, between you and I, give you a tool to remember these. Any acronym would be great, but here's one that I personally like. It is SUM, and I will write it out. Let me give myself some more space. SUM. So write this with me. Go ahead and jot it down. Grab a piece of paper. Some people, especially as they get older maybe, fear birthdays. So is that silly? Yes, it is. It's a silly little mnemonic. It's a tool that I can use. So if I'm thinking, okay, what are they again? I can say some people fear birthdays, and the first letter will remind me or help remind me of where they fit. So the transport layer, we're dealing with segments, that's the S. Network layer, packets, that's the P. Data link layer, F for frames, and bits for the B at the physical layer. So thanks for joining me, having some fun with this. It's important to be able to identify those. And one other tip, if you're studying or reading some material and you can't quite decide, are we talking about, layer 2 or layer 3? If you're given a clue, like they say packet or they say frame, that's a really good clue as far as the differentiator of which OSI.
Okay. Now, why did I put that in first? Because you're all sitting there. I could see, without even seeing a camera, some of you sitting there going, Claire's got with her exploded brain there, is going, oh my God, what have I let myself in for? Don't worry about it. I thought I'd throw in something hard to begin with, just to get you an idea of where we're going. So the 4 things that you've seen there, the protocol data units, are worth knowing first, because then it ties in with what we're going to do next. So when we're talking about that, we move down, and as stuff is passed down, what I'm going to do though, I'm going to miss out this part, and I want to go down, I want to come back to that. I'm going to go for the 7 layers of OSI model. Now, the 7 layers are application, presentation, session, transport, network, data link, and physical layer. Or, as the guy done in the last video there, saying to give a mnemonic just to say so you can remember it, all people seem to need data processing. Or, all people seem to need Domino's pizza is probably a better one. So, what you should do is remember this here, because you can see here that application, presentation, and session layer, if you look at these are the ones that are on your PC. As soon as it leaves your PC on a network, the 4 bottom ones, transport layer, network layer, and physical layer, all come into action. So as soon as it's leaving that network, whatever it is, wireless or whatever else, on your network, from your PC, on your laptop, or your phone, all of the bottom 4 then come into action. The top 3 all deal with what's on your device. So you can see that the data sits with all 3 there. When we go down the transport layer, it deals with segments. At the network layer, it deals with packets. At the data link layer, it deals with frames. And at the physical layer, it deals with the ones and zeros, which are like an electrical switch on and off, represented by a 1 and a 0. So that's it. It's either on or it's off. And that's how it's read. So binary. And that's what's sent. So, oh, that was the wrong one to go for. Idiot. Got them. Come back to the after this. Then I'll ask you a question. So OSI reference model. Now, the 7 layers. So start from the top, work your way down. Application, layer 6 is presentation, layer 5 is session, layer 4 is transport, layer 3 is network, layer 2 is data link layer, and layer 1 is the physical layer. It's not maths, it's just write this down. So you should get this. Miko, you know on set last year, you should have had this with Alan. You know it, right? Okay. You'll come in handy in the groups then. Okay, the 7 layers explained. Now, each layer, the lowest layers, 1 and 2, is the physical media, such as putting data bits on the network interface cards. Yeah, so your cable and whatever else. So when you've got your bit of hardware, it doesn't matter what network interface card or wireless or whatever else you've got, that's where the data is going to come from, and it's going to go into the network interface. So it's going from whatever medium. Now, again, the physical media will refer to how you're plugging it in. So you've got wireless, and then you've got your different connections, so coaxial, and so on. So I'll go into connections later. And it depends how it's connected, how fast it goes, and whatever else. And everything's decided down at that bottom layer how fast your data is going. So if you were on a fiber optic connection, you would expect your connection to go pretty quickly. So for those, it's like having Virgin and BT, I suppose. Virgin providing fiber optic straight to the home, and BT pretending to do. So anyway. The highest layers define how applications access things, and we'll go into each one. Now, each layer, I'll talk to the layer above and below. Yeah, so that's it, and that's all we talk to. So the networks, now you'll see when they're talking about things, they refer to it as packets. But when you looked at the protocol data units, it didn't refer to as everything as being a packet. Yeah, but it's a bit of a misconfiguration when we're talking about things. But we refer to the data as being in packets that get sent. Yeah, and we'll stick with that just now. So the network passes a packet from one software layer to another, and in the same order of the layers. So then what it is, I'll add additional formatting. So it'll maybe add an address or something where it's going. We'll get into that in a minute, how it works. After that though, once it gets to the receiving end, so it goes from one end to the other. So if we go back up to the graphic a second, you'll see here, we've got one end of the network. Yeah, so what we've got is, say you're sending a request, www. an HTTP request for Google, right? So HTTP : www.google.co.uk, right? So we know that that's sending an HTTP request. That'll come down through here. Once it gets to the other end though, then it gets stripped off all the way up to when the Google server, which will end up back up here. And then for them sending back the data, it has to come back from a machine on the other end in reverse and do exactly the same. And then you'll strip it down until it gets to you sitting at the application there. So for you to see that HTTP request, you had to have a piece of software. What would that be? Anyone? First, a browser. Yeah. So any browser, doesn't be Firefox. So a browser, as long as you've got a browser. So there you go. So that's what we're looking at when we're at the application layer. So that top layer, that layer 7, we're looking at the application to allow the users to see what's going on. Yeah. So yeah, Firefox, Edge, whatever. Now, after that, each layer appears to be communicating directly with the same layer on another computer. Now we'll look at each one. So start. This is the application layer. Now you'll see here a list of some protocols that are used. So DNS, DHCP, FTP, HTTP, which you should know already. IMAP, LDAP, POP3, RTP, RTS, RTSP, SSH, SIP, SMTP, Telnet, and TFTP. All protocols. Now we'll go into protocols later. When you start off in your network, it's always good to know your protocols. I've always said, if I was teaching a certificate class, I would expect them to walk away and know between 6 and 10 protocols. For an HN, if you're going to be serious about getting into cyber and whatever else and networking, and then, because you're going to need to know the protocols to see if you can hack through them. You should know around about 20 by the time you finish the course. Yeah, by the time you go to degree level, you should have knowledge, not maybe know them off by hand, but knowledge of about 50 at least. Okay, so that's where we're working. So these you're going to start getting used to. Anybody know any of them? DNS, DHCP, anybody heard the terminology before?
POP3's email, isn't it?
That's right, yeah. Anybody else? Shout them out. If you think there's any and you think know what they are, chuck an answer up in the chat. File transfer protocol, spot on, well done. Seen them on Pirate Bay. DNS, domain name system, well done. Simple mail transfer protocol, again, another email one. Yep, well done. Anyone else want to give it a go? DHCP? Tell me it is remote. Yep, well done. So it's SSH is the secure version, but we'll look at that later. You actually do this SSH in this as well, so hypertext transfer protocol. Yep. DHCP, anybody know? Dynamic host configuration protocol. DHCP hands out email addresses, hands out IP addresses to machines when you switch on. So it's all as a DHCP server stores IP addresses and hands them out. You're going to be using that later on. You're going to build a DHCP server layer, and you're going to hack into it. Oh, good. Now I'm getting a bad network quality, so if I start cutting out, I apologise. Okay, at the application layer, like I said, if you think about that as being the friendly face of the 7-layer model, because it's the only face you get to see, where you're actually seeing something in front of you. So if I was going to do DHCP, there's a program for doing it. If I'm using HTTP, there's a program for doing it. If I'm using SMTP, there's a program for doing it. You get what I mean? So everything that you've got there, there's always a program to do it. So down here, it gives it when this is application layer protocols programs in themselves. So FTP can be used by other programs, such as the simple mail transfer protocol, used by most email programs to direct data on the network. The lower layers support the tasks that are performed there, and these include general network access, flow control, and error recovery. Now, we'll get into them later. We'll work our way down. We're at layer 6 now. Now, you see layer 6 is a funny one, because what you've got is JPEG, MIDIs, MPEG, PICT, and TIFF. Yeah, encryption, decryption happens here as well. Now, why would the ones for pictures be there? Any idea? Why is it in there?
It's to be sensitive data.
Kind of. When you create a picture, each one of these has a compression technique. Now, it has to be compressed then to send on over a network or over the web or wherever it's going. Yeah. So before it goes on its journey, it has to be compressed. Now, when it gets to the other side, then it has to be uncompressed. So layer 6 on the way out, it gets compressed, and then layer 6 on the way in gets uncompressed, which then allows you to open up and paint or whatever you want to see it in your picture. Yeah. So all of the white, if you like, in a JPEG, all of the white is compressed right down. So anything that's in there, and it knows when it gets to the other side that if there's no listing for it, it has to be white. It's easy as that. So what it does is just fills all that in with white. So if you take away all the white out of a picture, then that cuts it down considerably and allows you then to change the size of it and send it away. Otherwise, all pictures would be massive and too big to be sending over the net. So there you go. Encryption and decryption happens here. Does anybody understand what encryption means? Anybody tell me? Encryption and decryption. What does to encrypt something mean? Making it unreadable. Was it the key? Using the key to hide the original content? Yes. Makes words not words. Aye. Suppose you're right. Yeah. Encryption we'll look at later as well. So I'll not go too much into it. It's not as hard as you think it is. Okay. So what it also does is defines the format used to exchange among network computers. So you've got dissimilar systems: IBM, Apple, Sun, all these different systems. They need to communicate, but they're all write in different ways and all send their data in different ways. So there has to be something to translate it. It's like if I would use my phone and Google Translate if I go abroad. So if I was going to Russia, I would just take my phone and talk into my phone and allow that to do the translation for me. Now that's exactly what this does. It does translation for you. So within the sender computer, the presentation layer translates the data from the format sent down to application into a commonly recognized intermediate format. There you go. So done. The presentation layer is responsible for converting protocols, translating the data, encrypting the data, and changing or converting the character set and expanding graphic commands. So it's responsible for your encryption. Also manages data compression, reduce the number of bits, which I've already said. And then the redirector, which redirects input-output operations to resources on the server, also works at this layer. When we go into the session layer, you'll see here that we've got, again, our protocols, NetBIOS, NFS, PAP, SCP, SQL, and zip. Now you'll recognise a couple of these. Yeah. Now what happens here is the session layer is real easy. This is what the session layer does. It makes a call, it says hello, and then that's you. When the call's finished, it hangs up, and that's it. So if you think about it like your phone, that's exactly what it does. It doesn't do anything different from what you're doing there. But it's responsible for managing the dialogue, so it performs name recognition and other functions, such as security that are needed to allow applications to communicate over a network. So you've got passwords and whatever else going on, any kind of way in, then it has to think about that. Then it synchronizes user tasks by placing checkpoints on the data stream. These checkpoints break the data into smaller segments, as you see where we're getting to now, for error detection. Now, an important of this is encryption and decryption. So you can see we've got two layers that are dealing with encryption and decryption, and they're the two layers that are directly involved with each other. It also implements dialogue control between communicating processes, such as regulating which side transmits, when, and for how long. So it's to decide, it looks at what's going on, it gets the information to say, okay, we're going to send you data, but I need to know who you are, how big you are, how much data I can send you at once, how fast I can send you the data, and all of this is decided here. Just making sense so far, guys? If you're not understanding, please, I insist, you just say, George, shut up, and tell me more. Everybody okay so far? Got one yes. Oh, and a thumbs up. Get lost. Claire, fine. Look, we'll go over it again anyway, so I wouldn't worry about too much about it, okay? Look at this again, but we'll go over it. It's just new, right? I know you're all into it. It's first day. Once you read this a couple of times, I know the 7-layer model is not the easiest thing on the planet to try and get your head around, but once you do, you've got it. And you'll look at this later and say, well, that was easy. Okay, the next layer, level 4, or layer 4. TCP, UDP, work at this layer. You can see, now I'll go into what these are. Remember, you know what TCP and UDP, it's supposed to be UDP, not UTP. Anybody know what they are? Remember, you've got TCP/IP protocols. Yep. Yeah, so it's Transport Control Protocol. I'll tell you what happens here. Look at this one. If this is your PC, how many people here stream movies? Yeah, from whatever, doesn't matter, or series or whatever. You do, right. That usually, do you ever find that it buffers?
Isn't it when
Never had that stopped and it's buffered. It's buffering, yeah. Sometimes that's using TCP. How do I know that? Because what TCP does is error checking to make sure that the data is getting to you. If it was using UDP, what would happen is, now it's happened, I've seen it when you're watching football, when I'm watching football, and there's nothing worse, it just stops and then restarts when it feels like it. But when it restarts, what it does is it misses you everything and it just starts where it is. So if it misses it 5 minutes, you're going to find that you've just lost that 5 minutes completely, because it's just sending a live stream and that's the end of it. Doesn't care how you're getting it. So UDP, TCP will say, have you got that? Have you got that? Have you got that? And it'll keep saying that. And you have to keep going, yeah. And then this goes, got it, yeah, got it, yeah. That's TCP. So this conversation goes on all day. UDP goes, here you go. And then just sits back and goes, that's it. Yeah, UDP just keeps giving you and ignores you. Spot on. That's why games, yeah, you're right, something's luck. So you now know the difference between TCP and UDP. So anyway, what you've got is, as it's ending, it repackages, sorry, I missed a bit. What we're looking for, packets are sent error-free in sequence without losses or duplication. Then what happens is it repackages the messages at the sending computer, dividing long messages into several packets, so you see we're breaking it down, and collecting the small packets together in one package. This ensures that the packets are transmitted efficiently over the network. Now, at the receiving end, it reassembles the original messages and then sends an acknowledgement that the message was received. Now, it might then, this is where we get the problem, this is where buffering goes on. I haven't received that part. Yeah, because it tells you what's coming, and then you get it, and then you go, no, I haven't got that. So it buffers, collects it, then runs again. And that's why you get lag and whatever else in games, and that's why you get lag when you're watching some of your live stuff on the telly or some of the stuff you're streaming. If a duplicate packet arrives, the layer will recognise it and get rid of it. So TCP and sequence package exchange are examples of transport layer protocols. Now, layer 3, the network layer, ICMP. ICMP is dead easy, that's a ping. IGMP, that's another one you use when you're doing Cisco networking. IPsec, IP version 4, which you'll get to know, IP version 4 protocols and IP addresses. IP version 6, which most things are using nowadays. IPX and RIP. Now, we'll get into what these are later on. Now, so what it does is it's responsible for addressing messages and translating logical addresses and names into physical addresses. So if I have a name on my PC, that's why it's always good to have a good naming convention when you're building PCs, because what I can do is ping the name, and I'll use the NetBIOS name that you've got, and it'll change that into an IP address for me. Or if I send an IP address, then it'll change the name of your computer for me, and then we can have a connection. It also does HTTP. When you send, say, www.google.co.uk, yeah, then it's not actually sending that. What it's doing is it's sending to an IP address, which is actually broken down into a bunch of binary, and it's sending that instead. So first, what it does first of all is pings out to say what is the IP address, and then it gets the IP address back, and then it just uses that for communication. So that's why they know when you're doing any dodgy stuff on your PC. So if anybody's got a dodgy IPTV and whatever else, that's why you're getting caught. Hide behind something and then you'll be fine. Now, anyway, as I was saying, also manages traffic problems on the network, switching and routing of packets. So we'll be looking at switches. Everything is converted to binary. If it goes over a network, it's converted to binary. Switching and routing comes in at this stage as well. So switching is for local networks. I'll show you, give demonstrations over the next few weeks of how networks are built and completed. And so when you're doing your networking with Ian, you'll find it even more there. And then he'll be talking about routing as well. And you'll learn a bit about routers. Now, I'll go over a bit of routing and whatever else with you soon. Now, anyway, if a network adapter on the router cannot transmit a data file as large as the source computer sends, the network layer compensates by breaking it into the data into smaller units. At the destination end, the network layer reassembles that data. So IP and IPX. So you can see we've got TCP on the layer above, and then IP at this layer. So these two make up TCP/IP. Now there is a TCP/IP protocol suite as well, which we'll get into later on. At the data link layer, which deals with a load of different things. Now these will be ways your networks and whatever else are made up. So it controls electrical impulses that enter and leave the network cable. Yeah. So on the receiving end, the data link layer gets raw bits from the physical layer and changes it into data frames. So what it's starting to do is convert from the binary into something that makes more sense and then passing it up. So the electrical representation of the data, the bit patterns, encoding methods and tokens is known to this layer only. So it has to find out what all these protocols are and find out what type of network it's connected to. Yeah, so this will be one kind of network up there. Okay, so it has to find out what it's connected to and what protocols they're using, and then this is responsible for fixing all of that so that you can actually get your data. So anyway, what it should do is anticipate the virtually error-free transmission over the network connection. Should do. When the data link layer sends a frame, it waits for acknowledgement from the recipient. The recipient layer detects any problems with the frame that might have occurred during transmission. Frames that were damaged are then resent, and it can be considered as having two sublayers as well, though. It has a logical link control, which presents a standard interface to the network layer, and then the media access control, which allows different network access types. Now, media access, or media, when we mention media in networking, is nothing to do with what you'd be thinking the word means. It's to do with the type of cabling that we're using, yeah, or the type of connection we've got. So that's the media. So it has to figure out how is it traveling, yeah, and what type of cables they're using and whatever else, or is it wireless or whatever. At the bottom layer, physical layer, Bluetooth, Ethernet, DSL, Wi-Fi, yeah, all of that is there. Now this is where everything's converted into binary, so a 0 or a 1. It's totally hardware oriented, deals with all aspects of establishing and maintaining a physical link between the two computers. So if I want to talk to something else, this is where all the link's done. And then it carries the signals that transmit data generated by each of the higher layers. So defines how the cable is attached to the network interface card. So it defines how many pins the connector has and the function of each pin. So it has a look at the actual connection and then decides how fast this is going to be, how's it wired up, and it understands all the different ones that are connected, and should be able to figure out what's been connected to me. Is it fiber optic? Is it using a copper cable? Whatever it's using, yeah. So it's got to think how fast can we send data. Then what it does is it sends all the transmitting the bits, zeros and ones. So it's saved as 1, not as a 0 bit, because different types of media transmit bits differently. The physical layer also defines the duration of each impulse and how each bit is translated into the appropriate electrical optical pulse for the network cable. Sorry. So it's deciding how these zeros and ones are going out there, how many zeros and ones can go out together without getting the network clogged up, and making sure that your transmission is as clear as it can be. Now, I'm going to go back up again. Yeah, and back to this. Now, tell you what I'm going to do. I'm going to use breakout rooms. Now, it will automatically be assigned. So, I'm going to get you to do something. What I want you to do together in your rooms when you get in there. Right, so, oh no, it's only giving me one room. Room 1, 20 people. That's not right. It's not what I want. I'm going to try this again. Right, try it again. Manually, create rooms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, Right, I'm going to put Callum, Chris, Claire, Fern into one room. Right, then I'm going to put Finn, Jack, Jake and James into another room. Jay, Caitlin, Leon and Liam into another room. Is this working? No, you're all unassigned. Hang on a second. Just sending it. I need a new room. Cancel. It's not going to work because I've got to create rooms. For God's sake. Add room. That's what I've not done. Add room. Sorry. I forgot to add rooms. There we go. Right. I'll try again. You've already got rooms. What for?
Tracy said.
Ah, but that'll be in her class. Is it not? Right, same participants. Right, okay. Ah, here we go. Right, so I put you in one. Ah. I'm just going to mix it up because I'm going to put room 1, 2, 3, 4. I'm just going to work my way down. So I'll come up slightly different from what I said. I'll tell you in a minute who's and what. And I get to room 2. Huh. It's coming up Liam. Oh, Liam, right. I've got you. Right, found you now. Right, there are 4 rooms which I've just created. Right, okay, so I'll go through. Callum room 1, Chris room 2, Claire room 3, Fern room 4, Finn room 1, Jack room 2, Jake room 3, James room 4, Jay room 1, Caitlin room 2, Leon room 3, Liam room 4, Liam Morgan room 1, Leif room 2, Lucas room 3, Maya room 4, Michael room 1, Owen room 2, Rick room 3 and Robin room 4. Now, when you get into your room, what I want you to do is go look at the 7 layer models and I want you to go research. I'm going to give you maybe about, let's think, 45 minutes. So let's say 3:15. Yeah, 45 minutes, 3:15. I want you to come back. What I want you to do is go research it between you and talk to each other and come back with an overview of a 7 layer model as found by yourself. So a bit of research between you. So hopefully there should be some people in each room who have an overview already and they should be able to help. Okay. So I'm going to assign you and then I'm going to move you. So I want in 45 minutes, we'll come back at 3:15, come back into this room and we'll discuss what you've got. So assign yourself someone to talk through what you've got. Okay. And we'll go through the 7 layer model when you come back. So I'm moving you now. Should be going to rooms. Are you going to rooms? Oh, right. Rooms are opening now, sorry. There we go. Open room. There we go. Right. Let's see. Take it, you're all going now, you should be. There we go. Good, 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 good. Right, we're moving now.